And now once we run this, you'll get a chart that looks as such. Okay, today we're going to do a slope chart, and this is really good at looking at a change over time between 2 time points of data to see if there's been an increase or decrease in that period of time. We're going to specifically be looking at GDP of continents or areas of the world. So I like to start with removing all of the data. If you have a bunch in your global environment, use rm list equals ls, and it'll remove and clear this out. You're going to need ggplot2 and scales. So if you don't have those packages already, load them now. We're going to set the theme to classic up front. That way our background is a blank slate. Now this data is from GitHub, and I will post this link below in the description for you to use. And what does that look like? We have continents. We have 2 columns, GDP of 1952, GDP of 1957. But there's an X there in front that we want to clean this up, so we're going to change the column names as such. Call names, data frame, because DF is our data frame. That's the area we're trying to change the column names. And we're going to change them as so. From left to right, continent, 1952, 1957. When we run this, we can see we got rid of that X in front of the date. Okay, from here forth, it's going to pertain to how we're going to plot this out. So our left label, we're going to paste continent for the year of 1952, and we're going to separate the value by a comma. So what does that look like? You'll see over here shortly. So it's going to show Africa and GDP. So continent, comma, GDP. Continent or region, comma, GDP. And that's for 1952. And that's going to be the left of our 2 labels on our plot. Now we have to do the other one, and this way we're able to set the parameters of change over time in GDP. Our right label is going to be the same thing, except our year is changed. And we're going to separate it by a comma again, and it'll look like this. Africa, that's the GDP. Americas, that's the GDP. Okay. Data frame class. Here we're adding a new column based on class data. So this is going to use an if-else statement. If-else data frame 1957 minus data frame 1952 is less than 0, it's going to be a blue line. So that means if the value between 1957 and 1952 is a negative, the line will be blue. So that means if it's decreased. Otherwise, if else, it'll be green. So if we've seen an increase in our GDP, the line will be green. Okay. This was originally red, but I'm against red and green on the same plot for colorblind friendly reasons. All right, now into our plot. ggplot data frame, geom segment. So the segment, we're going to go from X. So this is setting the X-axis up. X starts at a value of 1. X end is a value of 2. Y starts at a value of 1952 and ends at a value of 1957. And our colors are going to be based on class, which we see up here. And we can see here, class, it's going to give you a hint. Class, green, green, blue, green, green. Okay. So we've set our x-axis up and our y-axis and the color. Size 0.75, that's customizable, up to you. Show legend equals false. You don't always need a legend. What you put in the plot should be descriptive enough. Geom V line, so vertical line. We want the x-intercept to be 1 and the line type to be dashed. So this again is setting up the framework to show the change between 1952 and 1957. So we need the first vertical dashed line at 1 because we're starting at 1. Set the size what you want it, and then we set another vertical line at 2 because we end at 2. That's what this is doing. We're going to color manually. We're going to label it up or down. So if we see an increase, it'll be one color. If it goes down, we'll see it as another color. But we have to provide values to these parameters. So if we label it up, we want it to be green. If we label it down, we want it to be blue. You can choose any color you want. See, color of lines. We're going to label nothing for the X, and our Y is going to say mean gross domestic GDP per capita, gross domestic product per capita. So those are our axis labels. And we're going to set our X limit at 0.5 to 2.5, so that's going to be the range on the X scale. If we have it between 1 and 2, we don't want it to just simply be at 1 and at 2. We want it to expand beyond that just a little. And our Y limit is going to be 0. 1.1 times the max difference. So this is more of a formula. We're going to set the Y limit at 0, so baseline 0. And then we want to proportionately change it because the values of GDP are quite different. So we don't want to minimize that or, shrink the scale disproportionately. So 1.1 times the max of this and this. So that's going to create the proper range in our Y limit. Okay, so we're going to run all of this. We don't see it yet because we've shoved all of this into value P. Now we need to add texts. So geom text label is left label. Our left label will be Y equals to data frame 1952. This will be at vertical line 1, height adjust, and size. Now we're going to do the right label because up here, this is where it's pertaining to. So where are we getting left label again? Up here. Our left label is 1952, our right label is 1957. So geom text, what's the text of that right label? It's going to say 1957. And we're going to put it at vertical line 2, because again, we're doing our start and end at 1 and 2. Time point 1, time point 2. Okay. Geom text label time 1. And then this is going to be the parameters. Geom text label time 2. These are our titles. Okay. So we run all of this, bins it within our list of 11 values under P in that data, and then we're going to minify the theme. Theme, panel background, blank. Panel grid, blank, blank, and so forth. This way you have a really clean data set, and now once we run this, you'll get a chart that looks as such. Our y-axis is mean GDP per cap. You can change that if necessary. You have no tick marks here. You have no labels here. You have vertical line at time 1 as we set it, vertical line at time 2 as we set it. So this is 1957. This is 1952. This is 1957. You can see that there's a positive change for Oceania, Europe, Americas, and Africa, with a negative change for Asia. And that's why those lines are green and blue respectively. One thing I don't like about this plot as it stands is that we don't technically know. If you had no idea of the time change, you wouldn't know what year this is or this is if you didn't make the plot yourself. So let's go back up. We're going to make this, say, 1952. We're going to make this, say, 1957. So let's run this back, run this, and there you go. Okay, so this is how you can do a time scale and a slope chart to show economic change in a very simple manner. You could do this for a lot of different types of data. It doesn't just have to be economic. Perhaps you want to see a flux of change before a treatment and after a treatment in your ecological studies. So if this was bacteria, maybe you have Nitrous amonis. Does that increase after you burn a plot? Maybe you're talking about the amount of rain increase or the methane release on coastal areas where there's been sea level rise. Would that have a positive change or a negative change in certain atmospheric compounds? This chart can be useful. It's robust, and it's a precursor, that can catch the eye before you really dive into the data. Okay, that is a slope chart.